Hello everyone. In this video we will be learning about definite integral. When a function is continuous on an interval, then function is integrable on the same interval. This is very important information. When we have a function that's not continuous on an interval, then we cannot integrate it. If we try to integrate it, we will make a mistake. There is an exercise question that's about this, so be careful. If a function is continuous on an interval, then it can be integrated. Otherwise, we cannot find antiderivative. So what is definite integral? It is the integral that we have lower and upper bounds. We write the lower bound at the bottom, upper bound at the top of this integral symbol. How do we evaluate this? As in the first section, we're going to find antiderivative and write antiderivative. In this bracket, we will write the lower bound on the upper left, upper right, lower right corner, and upper bound at the upper right corner. And then finally we are going to evaluate the antiderivative at the upper bound and the lower bound, subtract the results. Okay, definite integral can be found by finding antiderivative and plugging the top value and subtracting off the bottom value. This is the way of finding definite integrals. So in finding different integrals, at the end we will have a number. We won't have a function. We will be evaluating the function, so we will have a number as a result. Let's take a look at some questions. First one, check it out 2a. And first thing to do is finding antiderivative. What is antiderivative of this function? Integral of x squared is x cubed over 3, and integral of 2 is 2x. I got my antiderivative. Now put bracket, put the lower bound here at the lower right corner, negative 2. Put the upper bound at the upper right corner. And then finally we do the evaluation. Okay, we want to evaluate that at our upper bound and then subtract from that and evaluate it at the lower bound one by one. Let's continue. On substitute 4 for x first. 4 cubed over 3 minus 2 times 4. Put bracket minus, because we are subtracting the results. Substitute negative 2 for x. Negative 2 cubed over 3 minus 2 times negative 2. So when we do these calculations, I'm not doing this step by step. I will get 12. Okay. This is pretty simple. The only difference is evaluating the antiderivative at upper and lower bounds and subtracting them. Another question, exercise 26. This is a common question. It came in Wezari 2 times so far. We are given this fraction. Before we solve these kind of questions, any type of question, actually remember from the first section, the first thing to do is rewriting the function. If we can rewrite and simplify in the first place, it will be better, easier to take derivative. Otherwise, it will take time. Maybe it will be impossible for taking the integral. So first thing to do is rewriting. So let's rewrite the given function. We have 1 minus sine squared at the top, cosine squared at the bottom. What is 1 minus sine squared in terms of cosine squared? Remember a trigonometric identity saying sine squared x plus cosine squared x being equal to 1. Since I need 1 minus sine squared, if I bring sine squared to the other side, I'll get cosine squared alone. So, in place of 1 minus sine squared, I can write cosine squared. so that cosine squareds cancel each other. We will be left with 1 only. So it will be integral from 0 to pi over 4 of 1 dx. Now take integral of 1, which is x, and we are going to evaluate this antiderivative at upper bound and lower bound. Let's substitute one by one. So it's going to be pi over 4 minus 0, pi over 4. Okay, the other ministry questions have the same idea, just the bounds are different. Okay, let's move on. Exercise 37. What's wrong in the following? The integral from negative 1 to 1 of x to the negative 2 is taking the antiderivative, increasing the power by 1 makes negative 1, divide by the same power, negative in front or in denominator, and evaluate this at upper and lower bound. It's going to be negative 2. So what is wrong? Isn't it the solution? Let's think about it. Let's think about the definition that we talked in the beginning. This information was telling us in order to integrate a function, we should have a continuous function on the given interval. So is our function continuous on this interval? From negative 1 to 1, is our function 1 over x squared continuous? This is the question. How do you figure out? Let's remember from chapter 2, to check continuity for fractions, we look at the denominator. What makes denominator 0 will be point of discontinuity. So our function is discontinuous at 0, and 0 is between negative 1 and 1. So since function is discontinuous at 0, then it means this function is discontinuous over this interval. Since x to the minus 2 is discontinuous on negative 1 to 1, or we can close it, doesn't matter, then it is not integrable. Okay, so we cannot integrate this function. In other words, if you draw a graph for this, 1 over x squared graph is, if you remember, like that. My drawing. This is x to the negative 2. We are evaluating this at, let's say, negative 1 to 1. And remember, integral is about finding finding the area under the function. So when you try to evaluate the area, you cannot. It goes to infinity. It's diverging. So there is no way to evaluate this interval, this area. So this doesn't work. This cannot be found. This cannot be integrated. Okay. So according to this information, I cannot integrate this because it is not continuous on the given interval. All right. Okay, let's continue with a tricky question. This is a test prep question, test prep 3, and it came in Wezari. Find the value of this limit. So it looks complicated. We have a lot of things. We have limit, we have 1 over h in front, we have an integral, a lot of things going on. But the first thing to do is always starting from the inside. Every time when we solve questions, we start on the inside. So this is the first thing to do. Let's do this integral. So what is this integral? This is definite integral. When I find antiderivative, remember I express antiderivative by using capital letter F. So it's going to be f of t, and the upper bound is x plus h, the lower bound is x. When I substitute upper and lower bound one by one, it's going to be f of x plus h minus f of x, right? This is what we have instead of this integral. Okay, don't write this integral, write this result. Now it's going to be limit as x approaches, as h approaches to 0 of 1 over h. So h is in the denominator of this result. Now let's go back to chapter 3. So when you see these kind of things, limit as x approaches to 0, or delta x approach to 0 of f of x plus delta x minus f of x over delta x. Remember this form? Does it ring a bell? This form is definition of limit. Right? So this is equal to finding this limit means, in a short way, finding the derivative of this function, whatever function we wrote here. Remember now? Okay, this limit form represents derivative of this whatever function we wrote here. So this represents capital letter f prime of x. If we say that this is the antiderivative, then inside the integral we have f prime. Right, this is the definition of integral. Remember from section 1, in the beginning of the section, when we talk about integral and finding antiderivative, we talked about this. If in antiderivative is capital letter f, then inside the integral we have its derivative, because integral is antiderivative, right? So I am looking for capital letter f prime. Do we have this in options? No, we don't. But when I look at the question, inside the integral, I have little f. So in place of capital letter f prime, we can write little f. So my answer is either capital letter f prime of x, or since question uses the little f inside, we can use little fx, which is option B. Okay, we also use this, remember, in the first section. We can either tell that the inside integral we have capital letter f prime, or we have little f of x. So I suggest you to go back to the first page of section 1 and remember this stuff one more time. Revise this stuff and you will understand the question easily. But the first thing to do is, starting from inside, find antiderivative and continue solving question with the limits. In order to solve this part, we need to remember some information from chapter 3, third chapter. Definition of limit, the definition of derivative by using limits, and we go back to the first section to remember this information. So there's a lot of things going on in this question. This is such a nice question. Okay, let's move on to a ministry exam question. Let me clear that. All right. Now, if the function has no point of discontinuity. Now, this is about chapter 2, section 4, right? So this is the combination of chapter 5, section 2. So there are two sections here in this question. If there is no point of discontinuity, then right side limit is equal to the left side limit, right? So limit as x approaches to 2 from left of the function is x plus 1 must be equal to limit as x approaches to 2 from right, whose function is ax plus 7. Now insert 2 for x. 2 plus 1 is equal to a times 2 plus 7. 2 plus 1 is 3 equals 2a plus 7. Bring 7 to the other side. Negative 4 is 2a. Then a is equal to negative 2. After we get the value of a, we can integrate this integral. Let's keep going. Integral from 2a 2 times negative 2, negative 4, 2a, which is negative 2, 3x plus a, which is negative 2 dx. Now we are done with chapter 2. Continue with chapter 5, section 2. Okay. Now, integral of 3x is 3x squared over 2. Integral of 2 is 2x. I'm going to evaluate this at negative 2 and negative 4. Okay, substitute negative 2 first. 3 negative 2 squared over 2 minus 2 by negative 2. I'm done with upper bound minus lower bound. 3 by negative 4 squared over 2 minus 2 by negative 4 is going to be equal to, let's evaluate, 2 squared 4, 4 and 2 simplifies 2, 2 times 3, 6, 2, negative 2, negative 2, 4, so this makes 10, minus 4 squared 16, 16 over 2, 8, 8 times 3, 24, minus minus plus 2 by 4, 8, so 24 plus 8 is 32. So 10 minus 32 is minus 22. Do we have this answer? No, we don't. So I made a mistake then. Let me see. Oh, I did not take the third power. Let me correct this. It's gonna be x cubed over 3, right? Cubed over 3. So let me clear this. Threes directly cancel each other. Actually, I don't need to involve 3 here. So when you do these calculations, result is going to be 52, which is option B. Okay, I think that's enough for evaluating integrals, definite integrals. Now let's continue with the definite integral as the area of the region. So when we are looking for an area under a function, the area between a function and an x-axis at 2 points, then in order to find this area, all we need to do is finding the integral between those two values. So we're going to find a definite integral from lower bound a to upper bound b of f of x will give you the area under this function, area between function and x-axis. Let's take a look at a question. Check it out. One, an administrative question. Find area of region bound by the graph of the function f of x sine x and x-axis and the two lines x equals 0 and x equals pi. Our function is sine x. Our graph of sine x is like this wavy shape, but we need the area under the function and the x-axis at those two values, 0 and pi. 0 is the x-intercept, pi is also an x-intercept, so there is no going down part, just this upper part. In order to find the area under this function between x-axis at these two, we are going to find the integral from 0 to pi of the function, which is sine x dx equals, the integral of sine x is negative cosine x. I'm going to evaluate the antiderivative at pi and 0. Okay, now negative in a bracket cosine pi minus cosine 0. What is cosine pi? Cosine pi is negative 1, cosine 0 is 1. We have negative, negative 1, negative 1, negative 1, negative 2, negative in front makes positive 2. Answer is 2. Okay. One last question. These are all related questions to this definite integral. 2023 first attempt. We are asked to find the area of the shaded region. The area is between 0 and 2. So we take the integral from 0 to 2 of this given function. 2 minus x square root of x. First thing to do before taking integral is simplifying, rewriting the function. Let's rewrite the function. I'm going to write this as, I am going to write square root of x as x to the 1 over 2 and distribute this function to the bracket. 2 times x to the 1 over 2 minus x times x to the 1 over 2. Add powers, 1 here, half here, 3 and a half. So we are going to find integral of this function. This is easier to take integral in this way. Now, integral of the first one, 2x, increase the power by 1, 1 over 2 plus 1, 3 over 2, divided by 3 over 2. When I divide 3 over 2, okay, let's do it as a second step. X, increase this by 1, 3 and 1.5 plus 1, 2.5, so 5 over 2 over 5 over 2. Let's simplify this a bit. 3 over 2 in denominator makes 2 over 3 in front. So 2, 4 over 3, x to the 3 over 2 minus 2 over 5 in front, x to the 5 over 2. 2 and 0. I'm afraid I cannot fit in here. Now I want to write this as radical x root of x minus 2 over 5 x squared root of x. We did this a lot in chapter 3 section 2, so I am skipping these steps explaining things. You know how to write them. I think you have to know by heart. Now let me evaluate at the upper bound. 4 over 3, 2 root of 2 minus 2 over 5, 2 squared, 4 root of 2. Minus, evaluate at 0. At 0 it's going to be 0. At 0 it's going to be 0. So no need. So now simplify this. Now I need to equalize denominators. Oh, it's going to take time. Multiply this part top and bottom by 5. The second fraction top and bottom by 3. Now it's going to be 4 times 5, 20 times 2, 40, root of 2 minus the second fraction, 2 times 3, 6, 6 by 4, 24, square root of 2 over 3 by 5, 15. Let's subtract the top. 40 minus 24 is 16, right? So 16 root of 2 of 15, which is option D. Okay, it seems complicated, but the complicated part is the basic math part. We know the steps. In order to find the area, all we need to do is finding the integral between 0 and 2, and we simplify the function at first to be able to integrate, and we take the integral. Taking integral and simplifying is annoying. The rest is easy. And then substitute the upper bound, substitute the lower bound, subtract off, you'll get the answer. That's all for this lesson. In the next lesson, I'll explain properties of definite integral.